All right, hey Luke and whoever else is watching this fifth period, this is 8.2. This is the Pythagorean theorem. And then something else called its converse. We're going to talk about that. But Pythagorean theorem should be pretty short. This should be a pretty short video. I did write one triangle that I see. This is a common mistake that I see people see a lot because of the way that this thing is positioned. Okay, so here's the deal. When you're doing the Pythagorean theorem, the most important side that you want to make sure you know in the actual formula itself is the hypotenuse.
Did Luke Olson come in?
No, he's at speech.
Oh, okay.
District speech. Most common mistake for the formula, you have to make sure you know where the hypotenuse is, okay? And when they face right triangles this direction, I have people that write the hypotenuse as the wrong side. Which side is the hypotenuse? The bottom side. This is the hypotenuse, right? But when it's sitting on its bottom side, a lot of people say that this is the hypotenuse because of the way it's slanted. Don't do that, right? The hypotenuse is the bottom side. It's always the one opposite the right angle, so don't make that mistake, all right? Let's go down. Let's do some hypotenuse, and then the other two sides are the legs. You'll have probably one short leg, one long leg. You could have the two legs being the same. Do you know what that looks like? A right triangle, but what kind of right triangle? It's an isosceles right triangle. What are these two angles right here? The same, and they are? It's a 45, 45, 90 triangle. We'll talk about those later. But this is a right triangle, but that is an isosceles right triangle. So this guy and this guy are the same. Okay. We'll talk about those later on. Let's do some theorems here, Pythagorean theorems. All right. X is what you're solving for. Which side is X? That's the hypotenuse. Okay. So a squared plus b squared equals c squared. We know this already. 6 squared plus 15 squared. I would really encourage you to do as much as you can in your head. So like some of these, like 6 squared, don't type that in. That's 36. 15 squared, you know what that is? 225. Did you do that beforehand? That was in your head? Something tells me you're lying. Anyway, 61, I think, equals x squared, and take the square root. We'll go ahead and figure it out as a decimal. Square root of 261, what do you got? 16.155. Let's go 16.2. We'll go one decimal place. Does it say? Nope. We'll just go one decimal place. So 16.2. I don't know that any of those work. No. 16.2. 16.2 is the hypotenuse. It has to be the longest side, so that seems appropriate. B. We are not solving for the hypotenuse on B. Which are we solving for? For a leg. What, do you want to call that A or B? B? So this is A and this is C? Sure. 9 squared plus x squared equals 11 squared. Do as much as you can in your head. 81 plus x squared equals, what's 11 squared? 121. Subtract the 81 over. This is the difference that you have to do. X squared equals something like 40, maybe? And when you take the square root, the square root of 40 is 6 point something. Anybody got it? Square root of 40? 6.3. Okay. Cool. All right, good? Okay. Are you listening to this next step? This is something that you maybe don't know already. Okay, but you should. Especially for the ACT, these will save you time, a ton of it, right? These are two that you should have memorized. You should have a 3, 4, 5 memorized and a 5, 12, 13 memorized, okay? Those are called Pythagorean triples, and the reason why they're Pythagorean triples is that those go into the Pythagorean theorem perfectly. Like if I would do a squared with the 3 and 4 squared with or b squared with the 4, it will come out to be 5 squared, right? Those don't have any decimals. Same thing with 5 and 12 and 13, right? Same thing with 8, 15, 17, 7, 24, 25. There's one more that I usually add to the list, and there's 9, 40, 41. Those 5, you might see every once in a while, those 5 triples, but you should have these two memorized. 3, 4, 5. Some of you do already. You know 3, 4, 5 triangles. Yes, do you? Maybe? So 3, 4, 5. 3, 4, 5. Just remember that. 3, 4, 5 is a special right triangle. 5, 12, 13 is another one. So get those stuck into your head right now. and then you can take shortcuts. No, the reason why you memorize those, I'm only asking you to memorize those two. The other ones you will see every once in a while, but not very often. But it is beneficial for you to memorize those two because it will save you tons of time, especially like on ACT day. Like, rather than having to do the a squared, b squared, c squared, if you see those, you'll be like, oh, I know what the answer is right away, right? They hide those in there. They want to see if you can save time doing that, okay? These are Pythagorean triples. Now, below each one of these columns, they have like 6, 8, 10, 9, 12, 15. Those are the same thing as 3, 4, 5s. They're just multiplied, right? Like if I take 3, 4, 5 and take it times 2, I get 6, 8, 10. If I take it times 3, I'll get 9, 12, 15. So all multiples of 3, 4, 5s are also 3, 4, 5 triangles, right? Same thing with 5, 12, 13. If I multiply by 2, I get 10, 24, 26. If I multiply by 3, I get this, etc., right? Any multiples of 5, 12, 13 come out, okay? 8, 15, 17, 7, 24, 25, and 9, 40, 41. Those are special ones, okay? So we're trying to save us time, all right? Looking at this thing right here. This is a triangle. Which one's the hypotenuse? 15. This is my biggest side right here, okay? Now, I'm going to look at 15 and 12. Those are the only two actual numbers that we have, right? Those are both divisible by 3, right? So what I'm going to do is I'm going to divide that by 3, and I'm going to divide by this one by 3. So 15 will become 5, and 12 will become 4. So what's the third side have to be? 3, except that was after I divide by 3. So I'm going to take that now and multiply by 3 to get 9. Look at how much time we saved, right? And you can do that even faster in your head, right? If you know those, you can do those really fast in your head. We don't have to do the full Pythagorean theorem. Make sense? Good? Do that as often as you can, okay? All right, let's go to the backside. Backside, backside, backside. Oh, man, look at this. Damon is locked out of the house. The only open window is on the second floor, which is 12 feet above the ground. He needs to borrow a ladder from his neighbor if he must place the ladder 5 feet from the house to avoid some bushes. What is the length of the ladder that Damon must need? Check out the diagram. Do you remember your stuff? What's the length of the ladder? Don't calculate it. Don't calculate it.
13.
5, 12, 13. It's a 13. We just know that, then we can skip steps, right? 5, 12, 13. Okay, 13 is the answer. It is C. Make sense? All right. It was a story problem, but it was like the fastest one of all. Okay. All right, here's the deal. Here's the deal. We're going to go down to example 4. And I'm going to give you a little cheat sheet over here. So there are 3 scenarios that you can happen. Woo. 3 scenarios. SCENARIOS. 3 scenarios. If a squared plus b squared is equal to c squared, what type of triangle am I looking at?
Right triangle.
I'm looking at a right triangle. Okay? But the Pythagorean theorem doesn't only work for right triangles. Okay? Let me show you this. I can do a squared plus b squared and c squared, and if a squared plus b squared is less than c squared, watch this. Watch this. If this happens, these two sides, even when I add them together, are still smaller than this one. This is only one side, but it's still bigger than the other two added together. That means I have one side that is really big. What does this mean?
Obtuse.
He's an obtuse triangle, right? So I can use the Pythagorean theorem to tell me not just right triangles, but obtuse triangles, okay? Do you see why that works? The two smaller ones added together are still smaller than the big side, right? That means I have one side that's really big, okay? Now, if it's the other way around, and a squared plus b squared is bigger than c squared, then that means my biggest side is still pretty small, right? My biggest side is still smaller than the other two. So what type of triangle do I have here? Acute. Does that make sense? Okay, so this is what all these boxes set up here. The Pythagorean theorem, inequalities, blah, 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 all that good stuff, okay? So if they give us 3 lengths, we can tell what type of triangle it is, right? I can tell which type of triangle. Now, make sure that the biggest side is your C. Sometimes they will give them to you in the wrong order. Do you know what I mean by that?
So how do you
Sometimes they'll say 16, 7, 14. What's my C?
shoot?
Not the last one, but a lot of people put the last one as the C, right? Okay, 16 or the biggest one is your C. So let's go 7 squared plus 14 squared, and I want to know what that is in relationship to 16. So I'm going to do an open circle. Okay, 7 squared is 49, 14 squared is 196, 16 squared is 256, I believe. 49 and 196 is 145 and 256. Is this a right triangle? No, because they're not equal. Okay? This is my inequality, which means that my biggest side is really big, right? 256 is my biggest side. That's really big. So this is what kind? Obtuse. Does this make sense? This is an obtuse triangle. My biggest side was really big. It was bigger than the other two even added together. All right, let's do this one. 9, 40, 41. 9 squared, 40 squared, 41 squared. We got 81. And do you know what 40 squared is? You should. 1600, right? So this is 1681. What's 41 squared?
What?
1681. 41 squared is 1681. So what is this?
Right.
This is a right triangle because they're equal, right? Make sense? Good? That's all, right? So Pythagorean theorem doesn't just work for right triangles. You can use that to figure out what type of triangles it is. And that is called the Pythagorean theorem converse. That was the title here. And it's converse. It's kind of looking at it backwards. Like if you know the sides, is it which type of triangle is it? Okay, that's the converse. All right, let's go to the homework assignment. Woo, we got lots of problems going on here.
Here, let's do 1 through 12.
All right, my
on skills
negotiator, what
practice.
you got? What?
1 through 12 on skills practice, and then 11 through 17 on practice.
I like it, Randy.
I'll take it. 11 through 17, story problem included. You can do the story problem, it's not hard. Okay, I will take that. You know, the 5th period class, I always tell them, like, Chase negotiated for this, whatever, and they're like, he did a terrible job. I wouldn't have done that. I'm like, I think it sounds okay. But anyway, so they don't ever like what you picked.
You just do one side of the paper.
I know, right? So, 1 through 12 on skills practice, that chunk, skip the bottom, and then do 11 through 17. I like it. That sounds good. Perfect. Happy Friday.